Okay, we are live here. There's a lot of stuff to do. There's a lot of stuff to do. The whole afternoon is going to be spent on robotic stuff. I have a few different things I could do right now. I think the most likely thing that we need to work on right now is going to be cleaning up just the ablations for the hyperparam sweep stuff, so I can get that merged in. Plus, it's like we need to make progress on the hyperparam sweep stuff, regardless of everything else going on. Like, there needs to always be some time to work on Puffer Research Core. So we will do that for the next couple hours. You go wash my hands. Is there some reason why, of all the space in a big room, the gnat always decides to fly right in front of your face? The 80, I think. And I need this new term for okay, so what we're going to do at the moment, where is it? We're going to figure out what was wrong with these graphs. We had very, very nice graphs before, and we have to see what happened with them. and be a little less focused on explaining things, though I will answer questions because, yeah, there's just a lot of work to be done this week. I took a little time off yesterday. Well, more than a little time off. I took most of yesterday off. Just because it was getting to the point where my productivity was just dropping. It's like I'd rather have the ability to focus for the week. You just need to take your mind off things for a little bit. Okay, so broke it. Hold on. Did I just... This looks fine, right? Okay. Synthetic log task. Synthetic log task, right? That was with 200 samples, right? I'm trying to figure out what was the result that I had originally. And if we have this reproduced or not. Actually, wait, that's a good point. Why was it fitting a line? Yeah, so this is what you were expecting, though this is not. Something very, very weird here. Hang on. Should be able to get it from this. Then it did this on linear? On log, I mean? Okay, so here you have this one, right? Yeah, see, so this one is actually pretty good, I think. 1.6. What we say at 45. 1.5 at 46. Or 1.6 at 40, yeah. So this is on par. This is pretty well on par. Like this is a very nice curve right here, right? These are the earlier points. So I think that this is pretty good. Do we not get this when we go back? So 10. Oh, it was on linear before, so that wasn't the issue. Okay, so we have this one here, right? Puffer. And I love this logo. He's so funny. Okay, so we can see there is what appears to be a quite substantial difference in perf between these two, right? Let's figure out why. Where do you make a diff? I don't want this in GitHub Desktop. Okay, there's compare. Can you paste in a fork, or I mean a commit ID, commit hash? Okay, so it's not in the UI. You have to change the URL. That's so stupid. Okay. So between these two, let's not roll these changes out because this actually could be it right here. In fact, that's super easy to test, so let's do that. Okay, that's it. We run. And in the meantime, we will look. Oh, hold on. Did I miss one? No, I didn't miss one. Okay, good. Synthetic base task. We don't. Hmm. This isn't even bad if you look at it. It's just okay, that's pretty weird. Yeah, it's just the early part of the curve. So I have these two now the same. I don't know if I forgot to commit this file back then or what. I have this uniform sample here. Maybe I handled this wrong. Hang on. Global search scale. Wait. That's weird. I don't trust this diff thing either, because this looks weird to me. Something screwy. Okay, here's the global search scale term, right? Times 5. Really? That seems very odd. I mean, we'll try it. I mean, it would be, was it 0.5 times this? Because it would be times 5, and then 0.1 times this. It would be very weird if that worked. Okay, that actually does pull it into what looks like a much better curve. Oh, you see you have these random samples all the way out here? Hang on. I bet you it's just this. No, this makes it worse. I'm gonna be back in a few minutes. I'm trying to think though. I'm gonna think about this. I'll be right back. Okay. So this definitely changes. What are all the other little tweaks I've made? Let me see. Okay, so global search radius, right? This gets overwritten. See if that changes anything. Okay, so you do actually get a little bit out of those extra points. Fine. What else? Let me double check something. Would it be the total time step somehow? No, this is identical. Hey, welcome. We're doing a little bit of hyperparam stuff because I want to merge some of this up for a collaborator of mine to use. And then we're going to be doing robotic stuff for the majority of today. In a couple hours, once Kyung wakes up. He's on West Coast. Took a little time off yesterday, so it wasn't live. And it was just getting to the point where my brain was just like skipping 30-second increments while I was working. So usually that tells me it's time to take a day off. Had a good time. It was good. Yeah, no, this is all identical. Okay, so it's gotta be then in the rest of it. I forget, were you working on an NVIN-C? I thought you had some stuff you were working on, or is that someone else? Learning negative CS. Oh God. Yeah. You should at least go take your Easy 5 on all those exams. Like, you will screw yourself over if you don't. But for a long term, yeah, it's not how you code. Yeah, this was clipped normal. First time viewer here, hello. I know almost nothing about machine learning or RL in general, but I'm quite interested, so yeah, welcome. If you do have a programming background, I have a quick start guide that is way less mathy than most of the stuff out there. It's kind of like a get into RL over a weekend kind of a thing. I'll put this in the chat. Yeah, it just gives sort of my perspective on a lot of stuff in a short list, like an actually pretty short list of good resources. Like the OpenAI spinning up one is pretty good, but it's like way more math and algorithms than you actually need, and nowhere near enough engineering. And so this is my take on it. Ah, welcome. That's so funny. You just have people sick of their crappy high school computer science classes. Ah, jeez. Yeah, I think that generally the best thing that newer-ish programmers can do, and you can have been programming for a few years, but without like any formal instruction, is to just go do Stanford's like CS 106X. Maybe they're better courses. That's the one I took because I went to Stanford for undergrad. So that's pretty good. Don't necessarily listen to them on code style or anything like that, but just for core algorithms and data structures and such, it was pretty good. It sucks that it's taught in C++ because it's just a pain, but no, it's okay. I mean, C++ is kind of an okay language to teach. I guess it's okay. Because the thing is, you need pointers. Um, you do need pointers, but it's also like you would like to have other data structures built in so that you don't, like that your lesson is focused on the data structure that you're covering. So I kind of get it. I honestly think it would have been probably easier in C, but they don't want to have to teach you like stack and heap and memory management, so I kind of get it. For the RL stuff, my guide should be pretty decent, especially it's less math than you're going to need anywhere else, and the math takes a while to get. So mean, my own math is pretty abysmal. Okay, so here, we already have the scores transformed. Oops. I think that this was the same algorithm as I have now. It's just for some reason I broke it somewhere. Let me see. So, set data, so it's training on normalized scores. So normalized is after transformed, right? Dang it. What's going on here is I have this really awesome hyperparam sweep algorithm, but when I went to clean it up, I somehow broke some stuff, so I have to fix this mess that I've made. Like you see, I cleaned up all the variable names and stuff. I mean, it's more than just that, otherwise that would be pretty easy to catch. Let me just go line by line here to make sure at least this portion is the same. So raw scores, which is y. Yeah, so raw scores is y. Mean, max, mean, standard deviation. Okay. And then we have transform scores, which I'm calling yt now. Negative log y over max plus f. This is good. Then you take mean, standard deviation, you norm. Okay, and then min, yt norm min. Is min of yt norm. Yeah, so this is the same, and then that function just gives you yt norm. So that should be fine. And then what do you do with it? You set data to norm, which is here. Train mode, you train it. Eval, yeah, this is all fine. Then next we get costs, which are here. We get log costs. We get max log cost here. Okay, and this is where something weird happened. So I do minus min divide by max minus min. And then I multiply by max minus min. So this cancels. And then I add the min. So these lines are completely redundant, right? Unless I use log cost. Hold on, do I use this somewhere else? No. So yeah, this was completely redundant. I don't know how I even did that. That's ridiculous. Okay. We want the highest cost one, which is just max here. And then the mean function gives you log C max, okay. Wait, did I not set the... Yeah, okay, because the mean score is allowed to be 0. Okay, this is fine. Normalize log cost. It's going to be log C. Train, eval. Okay, so this is all the same. This is identical so far. Predict and score. Where is it? Oh no, we have to do sample first. So you sample, get Pareto points, search centers, sample normal, which is the original sample that I had. This is the same. This 0.1 is fine because I made it 10x larger up top. Adjustments per Pareto. Number of candidates a little different, but we adjusted that already, and then you flip, fine. And then you just predict both of these, score cost on suggestions, right? Well, hold on. Yes, because the success observations are, wait a second. How does this work? Okay, so this works because the suggestion is already in the same latent space. So we do all these transformations, we maintain whatever the suggestion is in that same space, and then yeah, so then we fit the model to that. We're good. So now what do we have? So this is norms for me, and so we do the GP YT norm and then YT var, and then we have log cost and log cost variance. Anybody working on a Flappy Bird app? Actually, I think somebody just did one of those. I think you missed doing that by like a week. Who is it? Yeah, Luis Valero here has 1,000,000 step per second Flappy Bird. Flappy Bird's a nice little end for RL. I have not seen his code yet, so we will see how that looks. Okay, so this is a prime spot for error, potentially. So log cost standard deviation. So you take this, you subtract the min log cost, you divide by this term, and then you multiply by this term. Okay, so this is weird, but it does nothing. Log cost SPD S. Let me just make sure. Okay, so it's only used in the conservative. So we'll have to check and make sure we're not using these conservative numbers anywhere. But otherwise, that should be fine. Okay, so GPC is you just take X, right? And then we ignore all these conservative ones. Stacker. I don't know what that is. Oh, like the arcade machine? I don't know if this one is as good because this one is a purely mechanical game, man. Like, literally the whole difficulty of the game is the block moving too fast. So, like, I think it would be pretty boring to watch because it's just going to be the same exact action. I mean, it's literally like there's one state that you have to map to the action and that's it. I don't think that one would be as good. Did anybody ever figure out if those machines were rigged or not, by the way? Because those were always the machines that they had the really big prizes attached to. Like, you could win, like, a game console or whatever from those. So I assume that they were probably rigged. Yeah, but I mean, like, rigged in the sense of literally, like, you push the button in the right spot and it just fails it anyways. Like, that's, like, blatant, right? There's stuff like the basketball hoops where they make the hoop, like, they stretch the hoop a little bit. So, like, you basically can't get you can't make a basket if you bounce it off the backboard. You have to just hit it straight on. Like, that's one thing, right? That's just deceptive. Or like the like throw a ball at three stacked blocks. Like those are just deceptive, right? It's not actually like failing you behind the scenes. I don't even know if they still have carnivals like that, to be honest. That might be a boomer thing. Normalized Pareto. What happened to this? I think I have them just out of order. So okay, so Pareto, normalized Pareto scores. Well, wait, here you have Pareto Y, Pareto YT, and Pareto C. Okay. And then what do? I do cost difference is cost mean. So this is GPC minus Pareto costs. So Pareto C. So GPC minus Pareto C. Squeeze 1. Are these backwards? No, these are correct. Donkey Kong. Yeah, like any of the. I always tell people like any of the old arcade games are great little toy tasks to have. If you're looking for something like of middle complexity, like any of the old arcade games will be good. I think Donkey Kong there might be IP behind. Um, like there's, I know I tried Asteroids a while ago. Like that's a decent one. Space Invaders. There are all sorts of ones that can be done. Um, I mean, it's like there are a couple things here, right? I kind of just keep giving these out to people as projects for like newer people or like new to middle experienced people because like they're useful. More arcade games are good just to have more of them. We do learn stuff from those. So I think like yeah, any of those are fine. I think actually, you know what would be the most useful though? The original seven Atari games. There were seven Atari games that were used by the original DQN paper, and eventually I would like to have all seven of them. So, where is it? Beam Rider, Breakout, Enduro, Pong, Qbert, Sequest, and Space Invaders. So we have three of these, right? We have Breakout, Enduro, and Pong done. So these are the remaining ones. Um, I would suggest that you submit something a little bit more toy to me first, just because I know you're a newer programmer, and some of these could end up being more complex than I anticipate. Like, the thing with some of these is I expect that most of these would take me a day or two, but I could be wrong and they could be more complex than anticipated, and they could take me a week, right? With any of these. If they take me more than a week, then I guess I've just screwed up massively, but I would doubt it. Yeah, I would just do something like that. Just port some like simple little thing to see so I can look at the code, and that'll save you some time. Okay, so cost diff is correct, and then cost distance is the absolute value. Distance to nearest Pareto, min cost distance min of cost distance. So I have nearest, I got both of these. And then cost difference less than 0 gets set to infinity. Closest Pareto index. Okay, I think this is different here. Yeah, so this is probably the difference right here. Um, Let's see what this does. That was a legitimate difference. Let me explain what I did. So the way that this algorithm works, you have, why does it do that? You have points on a curve, like let's say, whoops. You have points on a curve like this-ish. And what if you're gonna put a new point in here, like let's say you put a point here, then the algorithm looks at this performance increase over the nearest point, and then it looks at this distance between points. So by mistake, instead of taking this distance, I also took this distance, which would give you negative values, which is wrong. Let's see if that actually changes anything or if it's still broken. Because it very well could just still be broken here. And it looks like it is. Yeah, that's actually more broken. Interesting. Let's see why that is. Okay, ratings are all 0. Did I get something wrong here? This is interesting. We just put a breakpoint. Oops. So none of these should be negative. Yeah, so they're just very low. Something's weird. GPC. 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 So it's GPC minus Pareto C. Wait, so it's... Oh, okay. This is fine. Why is this so small? I'm doing this in transform space, which is log space. Let me look at what I did before. So before I was doing unnormalized, hang on. This now looks the same. And it got worse somehow? Hmm. I mean, let's at least go to the no, we already have sample normal. Huh. We literally should have the same thing then. GPYT minus nearest Pareto YT times the nearest Pareto distance. Wait. Dist to nearest Pareto. Distance to nearest. So you take, this is your cost difference here. It's bizarre. Okay, what I can do is I can go check the magnitudes. Let's test neocarbs. Yep, so you can see that this one is way better, right? I forgot to visualize. Hang on, did I just not visualize before? I did. Okay. Yeah, because we were getting the, yeah, this is definitely wrong. Okay, so what we're gonna do is we're gonna go here. Yeah, so it is normal for this to be a very small value. Um, Ooh, this one is way bigger, the distance to nearest Pareto. Right? Yeah. Look at this. So we have, this was in the candidate process. There's no multiple here. Yeah. Let me see, so these initial points go up to like 18 and 20. Hold on. Or even 40 sometimes. And then my initial points. Wait, our seed data is totally off. Yeah. Hold on. We are training with, we have completely different seed data here. So you're screwed from the get-go. I mean, that should tell you right here, right? Okay, so right here, I don't know why this would make a difference. Let's see. Yeah, no, you can see that the cost is so much lower here. You know what? Whoop. I want to check something. Okay, negative 738. 3. Where is it? 0, 73833. 2, 4, 5, 5. Ah, the search centers are different. You see that? There are 10 parameters here. 7, 3. So wait, you got, there's a 0.2 here, and then 4, 5, 4, 5, 2, 4. Oh, okay, so there's just the addition of a 0.2 in here somehow. There's one extra parameter. It shouldn't affect anything. As well go see what it is, though. Mini batch size. Seem right? Mini batches. Mini batch size, yep. I wonder if that actually changes anything. That actually might. I think I have that in the formula, don't I? Maybe not. Okay, we still have low costs. I think that 6 is the outlier. Oh, we're getting 6s. So aside from that, hang on. We get these 0.5. Yeah, so this is all the same, and then it's 2.5 plus 2.5 at the end, yeah. Oh wait, did I change the task? I might have changed the task. That'd be a stupid thing, right? Thought I changed something here, didn't I? I'm not seeing it here, though. This looks the same. So weird. Okay, I hate to do this, but we've wasted enough time, and I'm gonna have to be done with this in an hour, so we're just gonna do it the stupid way. I can guarantee that this will work. I should have just started with this, I guess, but it's so rare that I break things this badly that I have to do things like this. But this will guaranteed work. Yeah, okay. Now we've got this. Wow, hold on. Okay, so here's our nice sweep curve. First thing, just gonna make sure that I didn't break anything with this. That's the same thing. We just got this point way out here. Hold on. I might have just found it and saved myself a bunch of time. Let me see. Did I just find it or not? Don't look like it. No. Hmm. Okay. If I literally paste all this in, it's just very weird because it would seem like this is not it would seem like this is not an issue with that. See? I'm just seeing if it's basically if the error is even in here at all. Because it doesn't seem like it is. Yeah, see, it's not in here at all. Actually, can I, hang on. Maybe I can find one of these samples from before. Yeah, very weird because, I mean, these samples look the same, everything looks the same. Nothing's freaking changed in this file. This is for sweeps only. This is not for testing. I don't know. Yep, that is weird. Well, I guess we just go from here. Okay, the next one I can do is still doesn't break anything. Hang on. Okay. I fix this. I actually don't know what I could have screwed up here. It's the crazy thing. Let's refix this thing. These look way better, right? Oh yeah, there we go. So this fix needed to be in there at the very least. Interesting. It's not trying to push farther away. So this gives you this nice log curve, but Oops. GPYT. Why are these YTs so small? Wait, something's screwy. Is there a reason to do the score in log space like this? I thought I had a cool transform here. Yeah, there is. It's not log space. It's a better transform than that. So YT. They do one YT norm here. And then GPYT multiply by standard deviation, add the mean. And then you do this minus this one. These scores are just ridiculous. I don't know, how are these all? Max score times. So these are all expecting to score less than, huh? Okay, wait, did we find something? I think we found something, maybe. Why? Yeah, this is GPY. Why? Well, that looks weird, right? Can you try that again? Oh, this is the score. Isn't it log 200 in this case? What's this do? I'm surprised that doesn't help. It does get the ratings to be a little higher. This is a log curve, right? It's just stretched. Doesn't look very loggy. Really? Just a very small scale. Mm-hmm. This should work, I would think. just take longer to figure this out or something? So this really should make, I mean, this law should push it towards higher and higher cost. Okay, now it has, no, it still doesn't have a decent cost model. Yeah, there it goes. Okay, this is way closer to what we would expect. I don't know why it just wasn't doing it before. Must have been like a save file, a weird bug. Okay. Yeah, so here it is jumping too far, and you can see it's got a few misses. So this should prevent it from doing that, we'll see. So that makes it explore too slowly. Very sensitive to that parameter. I think if we did like 60 experiments, so 50 runs, you would see it. I want to look at that behavior. I mean, we have the consistent like curve now. It's just a matter of getting it to be cleaner. Okay, I like these because these are actually accurately estimating the cost. I don't know how it jumps from 60 to 174 like this. That must just be the way that we have the cost space set up. This was better. Yeah, so this is better. This is very clean. There are a few misses that we've gotta look at here. we have at least a clean curve back. So I'm going to commit this current stuff. Okay. Some stuff to review. I really want to get time to finish this, but I've got a few other things to do today. So I'm going to go get some food before Chung is up, and I've got to start on that stuff. For folks in the meantime, if you are generally interested in the work that I do and are interested in RL, whether you are brand new or an expert, you can follow all this work on puffer.ai. You want to help me out for free, star the GitHub. Really helps it when we get the stars on the GitHub. Oops. This is one of the main progress metrics that I track to see how well we're doing here. 1603. If you want to get involved, join the Discord, discord.gg/puffer. You can also follow me on X for even more RL content. I've got a blog with lots of great resources and some additional articles on X that you can't find anywhere else. Thank you, and